Hi, everybody. This is Justina Osowska, the founder of Women in Blockchain Canada, and I'm really excited to be here. I'm here joined by Jordan Last, who is the founder of Demergent Labs. Hi, Jordan. How are you doing today?
Hello, I'm good, thank you.
Excellent. It was really nice to meet you at ETH Denver and learn about what you're doing and really want to introduce that to the audience. So I'll let you get started and let them know what you're working on right now.
Awesome, yeah. So, like you said, I'm the founder of Demergent Labs. We are a small software development company focused on open source developer tools for the Internet Computer Protocol created by DFINITY. So, we have a grant from the DFINITY Foundation to basically bring TypeScript, Python, and GraphQL to the Internet Computer so that you can write your applications. We call them canisters. They're
Mhm.
relatively equivalent to smart contracts. You can write these applications in TypeScript, in Python, and use GraphQL as your database. So we're just really trying to bring those Web 2 languages everybody knows and loves, just bring them straight over to a decentralized computing environment.
Mm-hmm. And I mean, for those who may not know what smart contracts are, uh, and who are just getting into the Web3 space and coming from Web2, um, could you just give a quick overview of that and why is Dfinity different when you deploy smart contracts, for example, let's say to other blockchains?
Sure. So, yeah, usually when I explain the concept of decentralized computing, I just go back to Bitcoin. Bitcoin, its white paper was released in 2008. It was the first, I'd say, major application of a decentralized computer on a world scale. And what Bitcoin lets you do is lets you send uh, these information, basically Bitcoin balances more or less anywhere in the world, and it's verified by many hundreds or thousands of computers, making it extremely secure. Most applications that we run, if they're running on your phone, if your phone shuts down, then that program terminates. Anything on your laptop, if it shuts down, it terminates. Anything on just one server, it shuts down, then that service is gone. And so, to make things more resilient, to remove points of failure, we can make things decentralized and replicated. And programs that run on these decentralized or replicated computers, uh, we've started to call smart contracts. And it might not be the best term or word. I like to just say it's a decentralized application, or it's just an application running on decentralized infrastructure. But yeah, a smart contract is just a program running on one of these decentralized computers. Ethereum is the next major improvement beyond Bitcoin. Bitcoin just let you send, uh, you know, very small amounts of information. Bitcoin balances more or less back and forth. Ethereum lets you write much more expressive programs. Like you can actually write, all kinds of things. It's virtually a Turing complete language. Um, and then beyond Ethereum, everybody has been trying to solve the major problems with Ethereum and Bitcoin, which is that they are very, very slow. Because they're decentralized and replicated, like I said, hundreds, thousands, maybe more of machines are all trying to execute the exact same code and same transactions, we call them, to make sure that it's secure. Well, that's really slow. Uh, so everybody's trying to scale. And Dfinity, the their foundation that created the Internet Computer Protocol, they have a specific design or set of designs and a set of trade-offs that they've chosen to try to scale decentralized computers.
Mm-hmm.
And I think the vision that their founder had back in 2017, that's when I discovered the project. I think 2016-ish is when they officially started the project. I was just captivated by just their idea of a true world or internet computer, something that eventually, you know, all computation more or less would be able to run on top of this decentralized environment. And so I love the vision. I love that they're trying to make like basically a decentralized cloud, and that's basically why I've chosen to be uh, in this protocol in particular.
Yeah, I mean, a lot of people don't understand that. a lot of the storage space for running these things is running on centralized servers, right? That's one of the things I think people are unaware of. So that's a very interesting thing I think people would really want to know about, and maybe I'd like to ask you to go into that a little bit, because people get the idea of things being decentralized and okay, that's great. So now we've made running a peer-to-peer system that's decentralized, but now the question is where are we running it? So just going over like what other problem beyond speed is DFINITY solving?
Yeah. So, yeah, you mentioned centralized servers and such. So, the, if you think about it, and centralization isn't necessarily bad in every situation, but it does bring some drawbacks. And I think the point of this whole blockchain decentralized space is to overcome those drawbacks and try to have as many of the benefits of centralization as possible. So, generally speaking, when you want to make a web application, uh, you're going to make your front end. That's going to be a bunch of static assets, HTML files, CSS files, JavaScript, TypeScript files, and you're going to deploy that to some kind of CDN. That CDN is probably owned and controlled by one legal entity, more or less, right? Like Cloudflare, Netlify, or something.
Mm-hmm.
And in the end, they have uh, more or less ultimate say over your application running. They need to follow laws and such, but it's pretty easy for them to just shut your accounts down. This happened to me actually just a few months ago. Luckily, I was able to convince them that my accounts should not have been shut down, um, and they reinstated it. But it was pretty scary. So that's one of the drawbacks is that you are beholden to just generally a single entity. So that's for the front end, and then for the back end, same thing. You're probably running on Amazon's hardware or Google's or Microsoft's. There are these very large cloud platforms that, again, have basically this unilateral control. And it's just there's some trade-offs to that. Also, you know, give up or if we think beyond just the fact that a single entity could decide to shut your application down, um, if you deploy an application to one of these clouds, depending on how you do it, it might not be automatically replicated. You might not have authentication and scaling and such built in. They do have some tools that might get you close, or maybe there in some cases. But generally speaking, on Amazon Web Services, which is what most of my experience is in, you're responsible to do a lot of this stuff. It's very complicated. You have to set up like load balancers and deal with port configuration and all kinds of crazy things. So the internet computer, sorry, and let's step back a little bit. Let's think of an application running on Ethereum. You might deploy your smart contracts to the Ethereum blockchain,
Mm-hmm.
and this will be running again on hundreds of thousands of computers around the world. The problem is because it's so slow, it's so expensive, it's so difficult to replicate everything. You can't really put your whole application on Ethereum and have everything replicated. Your front end is really not going to be going on Ethereum itself. If you have any kind of application logic beyond the core smart contract logic, like beyond the core financial or whatever stuff, your user accounts, I mean, there's all kinds of things that you might want to do with a web server. You're not going to deploy that to Ethereum. It really doesn't make sense. It costs, I don't know what the numbers are right now, but maybe hundreds of thousands or millions of dollars to store even megabytes to gigabytes of data. So you're just not going to do that on Ethereum. So what these decentralized applications have to do is go back to the traditional cloud platforms in many cases
Mm-hmm.
to deploy their stuff. Or people are starting to use IPFS, Arweave, and decentralized file systems, and there's all kinds of different choices to make.
Mm-hmm.
But I love the simplicity and the architectural choices of that DFINITY has made with the Internet Computer Protocol. Basically, one protocol that is a full cloud environment. You have your compute, you have your storage, um, all just together in one package. It is really a very similar experience to AWS Azure. You write your application logic, you hit deploy. That's 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 the basic idea.
Yeah, and I think the other thing I just want to mention as well, in addition to what you're saying, it also costs money when you're deploying a smart contract on Ethereum. And so whenever you need to make a change after you're done it, you're just making a new version as well because of how it's been built. So I think I just maybe want to also ask you, regarding governance and regarding like updates on DFINITY and things like that, so people can better understand um, that aspect of it as well.
Sure. So yeah, this is where the Internet Computer Protocol differs quite a bit from Ethereum and Bitcoin. Generally, on Ethereum and Bitcoin, when you deploy something, it is that's done. It's just there. It's really never going to go away.
Mhm.
And there are techniques you can use to kind of get around that. But generally speaking, things are what we call immutable. They do not change. On the Internet computer, things are mutable. It's much more like the traditional cloud environment. You can deploy an application and you can shut down the application. You can change the application. And this has trade offs. On Ethereum, you can deploy a truly autonomous piece of code that just runs. It's like it's just going to run. It's just going to be there. It really doesn't matter what's going on around it. It is going to be there, and that has some benefits. On the Internet computer, you can try to do that. You can deploy a canister or an application, and you can remove all controllers of it, all owners, so that uh, essentially no one can shut it down. Except on the Internet computer, you always have to realize that there is an entity. It's basically a DAO, a decentralized autonomous organization called the NNS, or the Network Nervous System. Basically, all holders of the Internet Computer Protocol token, disclaimer, I own this token as well. Um, all owners of this token are able to vote on the protocol, and they can vote for changes to the protocol. They can even vote to shut down a canister or to change a canister. So you do need to realize that on the Internet computer, everything you do is subject in the end to this DAO. On Ethereum, you are not subject to a DAO directly like that, though things on Ethereum can change and have changed in the past. So, there's just trade-offs and different ways of going about it.
Mm. Yes, I see. So you're basically saying when they're DAO, when you own tokens, then you can do votes on how the system is run. So like when, you know, that's why there was forks of Ethereum, right? Just, and for those who may not know, whenever people, let's say, wanted to make a change, because like what you said, it's immutable, those who want to make a change, they would basically have to create an entirely new chain. Whereas with internet computer, there's a governance structure that's involved. You are through the ownership of those tokens, based on my understanding, you're able to vote, and then changes can be made on chain to the protocol itself. Is that the correct
Yeah,
understanding?
more or less. Yeah, on Ethereum, you really just have to get a bunch of people to decide, like, okay, here's the new protocol software. Hey, miners, validators, are you going to run the software? Are we going to fork? It's a very loose process. On the Internet computer, it's nope. Here is a concrete proposal. It's going to change like this. If everybody votes for it, it just passes, and things change quite seamlessly.
I see. So everybody, like, I guess the infrastructure for the voting is more structured, and
Yes,
that's
it's
based
built
on
in. Yep.
ownership. And it's
They call it
yes,
on chain governance rather than Ethereum is more off chain governance.
understood. So then those people have to, I guess, separately decide and then deploy it on Ethereum.
Yes, exactly.
Okay.
Which comes with like I said, it comes with some trade-offs. On Ethereum, you have many independent groups or various independent groups that all have to agree to something. On the Internet computer, it's a lot easier for centralization to occur because people can. It's a liquid democracy system, so I don't have to vote directly on everything. I can actually delegate my vote. And right now, a lot of people have delegated their votes to the DFINITY Foundation. And so the DFINITY Foundation is able to pass proposals very quickly and very unilaterally because a lot of people follow them. So Is that a good thing? Possibly. Is that a bad thing? Possibly. They're just different systems with different properties.
Yeah, I hear you. So it's like who makes the best decision, that depends on the system, but it's just an overview of how things work. The other thing I want to go over, which I find people are pretty interested in, and it's important, is the ability to enter systems and also the cost of running things. Based on what I was looking and I was reading on the DFINITY website, the cost of running things on DFINITY, and from what I noticed, it's much cheaper. So maybe you can explain that a little bit and like advise people on why that is.
Sure. So yeah, if we talk about costs as just a general heuristic relative to Ethereum or Bitcoin, the costs are going to generally be much, much, much cheaper relative to centralized cloud platforms like AWS and Google Cloud and Azure and such. Um, Depending on what you're doing, it'll probably be more expensive. So we're kind of in the middle between the centralized platforms and the decentralized platforms in the cost. Um, how costs are determined is everything is all computational resources are metered with a unit called cycles, and a cycle it really represents like a CPU cycle or a unit of bandwidth or something. It's just the unit that you use to count up all the computational resources, and the cycles have a cost. Basically, 1 trillion cycles is one. Uh, it's a one unit of a currency called SDR or XDR, special drawing rights, which is a collection of fiat currencies. So it's about, I don't remember, it's like $1.30 to $1.40 something. So a trillion cycles is about $1.40, $1.30. And basically, as you're running your application, the protocol just counts up all the cycles and says, okay, well, for this message or transaction you want to execute, it costs this much. And your application or your canister has a balance of cycles, and it's just the balance is always decreasing based on the cycle usage, and anybody is able to top up the canister to keep it going. It's very similar to gas on Ethereum. The unit of computation on Ethereum is called gas, and yeah, every transaction costs gas. So same concepts. How does an intercomputer get much cheaper costs than Ethereum? Well, basically, it's a lot less replicated. You don't have thousands of machines replicating everything. In fact, you have between like 13 and 40 machines replicating each application. And the intercomputer splits up the network into many smaller blockchains instead of one giant blockchain. And these blockchains are called subnets. Subnets, you deploy your application to subnet. Subnets can talk to other subnets. And yeah, that's a general gist.
So based on my understanding, that sounds kind of like what Polkadot does with its parachains, and they're specialized and they have like the ability to talk to each other. So that means you can like move an asset from one place to the next. So basically, would you say DFINITY is kind of like layer zero, providing the security for the entire protocol network, whereas like the subnets specialize in what they do, or like how would you help people understand that comparatively to other protocols?
Yeah, so at the highest level, I'd say it's a transparently sharded uh, protocol. Each subnet is a shard. But what's special and really nice about the intercomputer is that each subnet or each shard is a general purpose shard, generally speaking. You don't have to deploy a special subnet for your application. You can, and there are a couple special subnets, but basically every subnet has the same computational capability as other subnets. Now there's differences in size. There's certain parameters you can change, but generally it's just a subnet. And as an application developer, you don't necessarily have to deal with like my understanding of Polkadot. I haven't studied it super in depth, but it's been
Mhm.
around. So it seems like a very different system, much more uh, constrained in certain ways. It sounds like from what you're saying, like yeah, I mean, it seems like you have to rent these chains. Also, I might be not
No,
explaining it
you're
right.
correct. People vote, and that decides which ones get their slots because there's only so many slots. So there is a governance component to it. But yes, they have a protocol which allows them to speak to each other. So that's why I'm just like conceptually, I think it would help people to understand. But what you're saying is you just could pick a subnet and they're general purpose subnets. Whereas I think the ones for Polkadot are specialized like they're not called they're parachains, they're specialized in what they're doing. And they do have special purposes and people can build applications on top of that. But what it sounds like is what you're saying, it's not really like that. What you guys, it's so maybe you can go over that, like
Sure.
general
Yeah,
purpose.
right. Generally speaking, right now, if you want to deploy something, you just write your application, you hit deploy, it's just going to send your application to a subnet. Like to you, you don't even have to think about it if you don't want to, and it
Hmm.
will just go out there. And if you want to talk to other canisters, you don't really need to think about, and there's some nuance to this, like they're introducing new subnet types that might have special rules, but the application subnets, um, if you want to talk to a canister, you don't necessarily need to worry about where it is. You just create a cross canister call, which is kind of like an HTTP request, just a general purpose call to some other address somewhere, and it will just be routed to it, execute, and be routed back. And you don't need to think about it. It is, there's more latency when you go across subnets, but like
Mm-hmm.
it's very general purpose. I think that is the huge difference and selling point of the internet computer. It is a general purpose, decentralized cloud computing environment. It is, you don't have to jump through all these hoops and deploy your own infrastructure and do all these crazy things. The point is to just write your application, hit deploy. There you go.
Yeah, I mean, that's one of the things that I feel like I'm attracted to and getting to know about it because I mean, I work with developers. One of them, as you've met him as well, knows TypeScript. So I think the idea of onboarding people that don't have to learn an entire new set of code uh, is just also good because that means you can onboard those from Web 2 to Web 3 in a more streamlined fashion. I know that's something that you're working on. So I think to close off this conversation, I'd like to go over that. So yeah, how can we get more Web 2 devs into the Web 3 environment and what are you doing about it?
Yeah, I mean, our whole thesis at Demergent Labs is don't make people learn new languages. Don't make people learn new concepts if they don't have to. Let them use TypeScript. There are millions of TypeScript developers that have, and if we talk about JavaScript as well, that have decades possibly of experience or at least decades of material available to them. Same with Python. Um, just let them write applications like they always have. And so that's what we're doing about it. We're enabling people to use these tools. We're trying to build educational materials. We're working with people like you to teach people about this. And I think all we need to do is the we need to explain in clear detail the pros and the cons of Web3 and decentralized computing. There are reasons you would want to use it. There are reasons you wouldn't want to use it. And if people can clearly understand those reasons, they can make choices for themselves. And if we remove as many barriers as possible, I don't know. I feel like that's the best we can do.
Yeah, I agree. I mean, one of the biggest things I hear when I talk to companies, when I go to these conferences, there's not enough devs, there's not enough devs, there's not enough devs. It's not that there's not enough devs, it's just there's not enough devs who know how to code in specific languages, right? And I really like the idea that you're doing that. And the other thing that I really enjoy hearing is that basically what you're saying is that, hey, people already know how to do this. Let's not reinvent the wheel. So it's like a low hanging fruit. People already know this. They have years of experience. Now they don't have to upgrade all of their skills. They can augment their skills, but they don't have to learn an entirely new language. I guess maybe, yeah, they are upgrading the skill because they're learning how to like do something else with the code, but they already know the code. So I think that's what I like hearing, because it must be difficult for some people, they may not who has also the time to completely reemerge and like I also like the perspective you're providing, which is there's pros and cons to everything, things being centralized, things being decentralized, that, let give the choice to the user what they want to do. Um, so yeah, I think going forward, it's important that the community learns about these things, is educated and knows. But I also want to mention that essentially the interesting thing for me that you said as well is that people on internet computer don't have to think of everything that's going on in the back end. With these general purpose subnets, what it sounds like is once they've built the code and they've deployed the smart contract, or also known as, what did you say it's called?
Canister.
Canister, then at that point, they don't really have to worry about all the backend infrastructure either. That's already taken care of on the back end. So,
Yep, yep. There's some scalability issues like you can't deploy a Twitter, with millions of users and such. So you'll reach some limits, but they're actively working to increase the limits. But yes, that's the idea. You just deploy, and so much of it is just abstracted away from you.
yes, look, the way that I see it, even with Ethereum, we're looking at layer threes. People are just closing off on building out layer twos and that have the proper security, which I'm sure will over time find other things. But like you said, scaling is still an issue, I think, for everybody, even actually in the Web2 world. Um, you know, so I don't think this is a new concept, but I think this, yeah, like I think you've also mentioned this earlier. There's a cost to everything, right? And you have to really ask yourself the question, like, why would I build it out on the blockchain? What am I doing and what is correct for me? So that's what we're doing. We're educating people about the different kind of blockchains that exist and then giving them the choice. So thank you very much. And how can people reach you?
Oh yeah, my handle on Twitter or Telegram is, and my account on GitHub, basically everywhere. Last MJS. My last name is Last LAST MJS, and that's how you find me. Or Demergent Labs. That's my company. We also have a Demergent Labs Twitter account, Demergent Labs GitHub. We are software engineers, so we are just go to GitHub, look at our stuff. That's where we're doing everything.
Yes, and something else too. What for those who are interested in DFINITY, where would you like? Is there another place that you feel like people can find resources? What are you looking for? Like you said you were looking to get people onboarded. So is there something else that you're doing that people should be aware of?
Oh, sure. Yeah, if you go to the Demergent Labs Twitter account, right now we're doing it's called Azel Academy. Azel is the TypeScript um, development kit. We are mentoring people one-on-one. For right now, it's a simple 1 hour session. And the point is to get you bootstrapped, get all the stuff installed, and have you deploy your first application locally. We have a couple spots left for that. And we'll probably be doing those on a continual basis. So yeah, just go to our Twitter to see that. If you want to learn about the Internet Computer or DFINITY, internetcomputer.org or DFINITY.org will help you. And then there is a Discord for Internet Computer, developers. We are active in the TypeScript channel and the Python channel for our stuff. So I don't know. There's a lot of resources. Maybe I can send you some links if people have them. But yeah, just find the Internet Computer communities on Twitter, probably, and then you'll find everything. Everybody's talking about it. So in that community.
Okay, well, that's great. And I think to add to what you're saying, once I'm done posting this on YouTube, we could post some links underneath so people can get in touch with you with all the links and also to give them the guide to where things are on ICP so they don't have to be going all over the place. So anyway, thanks for that. That was great. A lot of good content, and I look forward to continue to speak with you.
Sounds great. Thank you so much.
Thank you.